Myself Megha Rathod. I am teaching maths in LPSAVANI VIDHYABHAVAN. Today continue chapter number 8, Quadrilaterals. And now today we start exercise 8.2. In exercise 8.2 we read the question from the textbook. So everyone take out your textbook and page number 150. I read the question number 1. ABCD is a quadrilateral in which PQRS are the midpoints of sides AB, BC, CD and DA. AC is a diagonal. Show that SR parallel AC is equal to SR is equal to 1 half AC. PQ is equal to SR and third is a PQRS is a parallelogram. This is a question. Now here answer number 1. In given you have to write ABCD is a quadrilateral in which PQRS are the midpoints of sides AB, BC, CD and DA and AC is a diagonal. This is given. Now in to prove, first SR parallel AC and SR is equal to 1 half AC. Second, PQ is equal to SR. Third, PQRS is a parallelogram. In figure is given here, so you will not get the marks for the figure. Now proof. In first, in triangle DAC, S is the midpoint of DA and R is the midpoint of DC. SR parallel AC and SR is equal to 1 half AC. Midpoint theorem. Second number, triangle BAC. P is a midpoint of AB and Q is a midpoint of BC. PQ parallel AC and PQ is equal to 1 half AC. Reason is midpoint theorem. But from 1, SR is equal to 1 half AC. So we can write that PQ is equal to SR. Now third, PQ parallel AC from second and SR parallel AC from first. So PQ parallel SR, two lines parallel to the same line are parallel to each other. Also PQ is equal to SR from 2. So PQRS is a parallelogram because quadrilateral is a parallelogram if a pair of opposite sides are parallel and are of equal length. Question number 2. Read from the textbook. Page number 150. ABCD is a rhombus and PQRS are the midpoints of sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rectangle. Here figure is not given. We have to draw the figure ourselves. So you will get for the 1 marks for the figure. Here given ABCD is a rhombus. PQRS, the midpoint of AB, BC, CD and DA respectively. PQ, QR, RS and SP joined. To prove PQRS is a rectangle. Construction. Join AC and BD. In figure you see ABCD is a rhombus. PQRS midpoint of AB, BC, CD and DA. Here join AC and BD. We draw the figure and also we join and AC, BD and intersects at O. Now we prove in triangle RDS and triangle PBQ, DS is equal to QB, half of opposite sides of parallelogram ABCD which are equal. DR is equal to PB, same thing, half of opposite sides of parallelogram ABCD which are equal. Angle SDR is equal to angle QBP, opposite angles of parallelogram ABCD which are equal. So triangle RDS congruent triangle PBQ by SAS rule. Then SR is equal to PQ by CPCT. Now in triangle RCQ and triangle PS, RC is equal to AP, half of opposite sides of parallelogram ABCD which are equal. CQ is equal to S, half of opposite sides of parallelogram ABCD which are equal. And angle RCQ is equal to angle PS, opposite angles of parallelogram ABCD which are equal. So triangle RCQ congruent triangle PS by SAS rule. Then RQ is equal to SP by CPCT. In PQRS, SR is equal to PQ and RQ is equal to SP. Then PQRS is a parallelogram. Now in triangle CDB, R and Q are midpoint of DC and CB. So RQ parallel DB and RF parallel EO. Similarly, RE parallel FO. So OFRE is a parallelogram. Angle R is equal to angle EOF is equal to 90 degree. Opposite angles of parallelogram are equal and diagonals of rhombus bisect each other at 90 degree. Thus, PQRS is a rectangle. Here we complete our proof. Now, in question number 3, read the question from the textbook. ABCD is a rectangle and PQRS are midpoint of sides AB, BC, CD and DA respectively. Show that the quadrilateral ABCD is a rhombus. Now, you see here answer number 3. In given, you have to write ABCD is a rectangle. PQRS are the midpoint of AB, BC, CD and AD respectively. PQ, QR, RS and SP are joined. To prove quadrilateral PQRS is a rhombus, and in construction, join AC. Here figure is not given. We draw the figure ourselves and you see the figure here. And you will get the 1 marks for the figure. Now in proof, in triangle ABC, P and Q are midpoints of AB and BC respectively. So by midpoint theorem we can write PQ parallel AC and PQ is equal to 1/2 AC. This is number 1. Now in triangle ADC, S and R are the midpoints of AD and DC respectively. By midpoint theorem we can write SR parallel AC and SR is equal to 1/2 AC. This is number 2. From 1 and 2 we can write PQ parallel SR and PQ is equal to SR. So quadrilateral PQRS is a parallelogram. This is number 3. Now in rectangle ABCD, AD is equal to BC, opposite sides multiplied both sides 1/2 1/2. So 1/2 AD is equal to 1/2 BC. So AS is equal to BQ. In triangle APS and triangle BPQ, AP is equal to BP because P is the midpoint of AB. AS is equal to BQ. We proved. And angle PAS is equal to angle PBQ, each 90 degree. So we can write that triangle APS congruent triangle BPQ by SAS rule. Then PS is equal to PQ. This is number 4 by simplicity. So from 3 and 4 we can write that PQRS is a rhombus. Because in 3 you prove PQRS is a parallelogram. And here we prove all sides equal. So PQRS is a rhombus. We proved here. Now in question number 4. You take out textbook and read the question. Figure is given in this question. ABCD is a trapezium in which AB parallel DC, BD is a diagonal, E is a midpoint of AB, AD. A line is drawn through E parallel to AB intersecting BC at F. See in figure 8.30. Show that F is a midpoint of BC. Here you see the figure and write the given. In question answer number 4, you see given. ABCD is a trapezium in which AB parallel DC, BD is a diagonal and E is the midpoint of AD. A line is drawn through E parallel to AB intersect BC at F. Now to prove F is a midpoint of BC. Now in proof, let DB intersect EF at G. In triangle DAB, E is a midpoint of DA and EG is parallel AB. So G is the midpoint of DB by converse of midpoint theorem. Now in triangle BDC, G is the midpoint of BD and GF parallel AB parallel DC. So F is the midpoint of BC by converse of midpoint theorem. Thus we prove F is the midpoint of BC. Question number 5. In parallelogram ABCD, E and F are the midpoints of side AB and CD respectively. See figure 8.31. Show that the line segment AF and EC trisect the diagonal BD. Here figure is also given. Now answer number 5 given. In a parallelogram ABCD, E and F are midpoints of sides AB and CD respectively. In to prove you have to write line segments AF and EC trisect the diagonal BD. What is the meaning of trisect? Means equal 3 parts. Make the equal 3 parts of diagonal BD we have to prove. And figure you can see here. And now here proof. AB parallel DC, opposite sides of parallelogram. AE parallel FC, this is number 1. Now AD parallel DC, opposite sides of parallelogram. So we can write 1/2 AB is equal to 1/2 DC. Then AE is equal to CF, this is number 2. Now from 1 and 2 you can see AE parallel FC and AE is equal to CF. So we can say that AECF is a parallelogram because quadrilateral is a parallelogram if a pair of opposite sides parallel and are equal to in length. Now EC parallel F, opposite sides of parallelogram AECF in triangle DQC, F is the midpoint of DC and FB parallel CQ because EC parallel AF. P is the midpoint of DQ. By converse of midpoint theorem, DP is equal to PQ. This is number 4. Similarly, in triangle BAP, BQ is equal to PQ. This is number 5. From 4 and 5 we can write DP is equal to PQ is equal to BQ. Line segments AF and EC trisect the diagonal BD. Here you can see, because DP is equal to PQ is equal to BQ, it means line segment F and EC trisect the diagonal BD. Now question number 6, read from the textbook page number 151. Here figure is not given. Show that the line segment joining the midpoints of opposite sides of the quadrilateral bisect each other. Here he give the question in word language fully, but you draw the figure, give the name and write the given and to prove in mathematical language. Now answer number 6, given ABCD is a quadrilateral. PQRS are the midpoints of the sides DC, CB, BA and AD respectively. To prove, PR and QS bisect each other. Construction, join PQ, QR, RS, SP, AC and BD. This is the construction. Dotted lines are all the construction. Figure you can see here, ABCD are quadrilateral. PQRS is midpoints and we joined all the points and dotted points. This is the construction. Now in proof, in triangle ABC, R and Q are the midpoints of AB and BC respectively. That means RQ parallel AC and RQ is equal to 1/2 AC by midpoint theorem. This is number 1. Similarly, we can show that PS parallel AC and PS is equal to 1/2 AC. This is number 2. From 1 and 2 we can write PQ parallel PS and PQ is equal to RQ is equal to PS. Thus, a pair of opposite sides of quadrilateral PQRS are parallel and equal. Thus, PQRS is a parallelogram, but the diagonals of parallelogram bisect each other. So, PR and QS bisect each other. Here, now question number 7. Read the questions from the textbook. Here, give the question. ABCD is a triangle, right angled at C, a line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. Now show that first, D is the midpoint of AC, second, MD parallel AC and third, CM is equal to MA is equal to 1/2 AB. Answer 7, given ABCD is a triangle, right angle at C, a line through the midpoint of hypotenuse AB and parallel to BC intersects AC at D. To prove, first proof, D is the midpoint of AC, second, MD parallel AC, third, CM is equal to MA is equal to 1/2 AB. You see the figure here. Here, triangle ABC, C is a right angle and join DM and MC. In proof, first, in triangle ACB, M is the midpoint of AB and MD parallel BC. So, D is the midpoint of AC by converse of midpoint theorem. We can write directly. Now, second, MD parallel BC and AC intersects them. So, angle ADM is equal to angle ACB, corresponding angles. But angle ACB is equal to 90 degrees given. So, angle ADM is equal to 90 degree also. So, we can write that MD parallel AC. Now, third. Now, in triangle ADM plus angle CDM is equal to 180 because it is a linear pair. Here, ADM is equal to CDM is equal to 90 degree. So, now, in triangle ADM and triangle CDM, AD is equal to CD. D is the midpoint of AC. And angle ADM is equal to angle CDM, each 90 degree. Then DM is equal to DM is common. So we can write triangle ADM congruent triangle CDM by SAS rule. So we can write MA is equal to MC. But M is the midpoint of AB. So we can write MA is equal to MB is equal to 1/2 AB. But you see, MA is equal to MB is equal to MC. So we can write MA is equal to MC is equal to 1 half AB. It means CM is equal to MA is equal to 1 half AB. Here we completed exercise 8.2 and also completed chapter number 8. So everyone have to write all the examples, important notes, all the theorems and all the sums of exercises without questions. You have to write in your fair book compulsorily and complete your fair book.